done at 3-week intervals. As each frame is removed from the hive, those covered by bees are counted. This is a very simple way of estimating colony strength. Any differences in development could be due to genetic factors, and this character could be important for the exploitation of certain crops. A thorough inspection of the brood nest is now made frame by frame. Every colony should have a frame for the construction of drone comb. In this case, the frame is subdivided so that some of the drone brood may be removed and distributed for breeding purposes. But no drone brood may be removed when the development of varroa populations is being investigated. When the queen is found, her identity is checked and she is examined for injuries. All breeder queens should therefore be marked for life with coloured and numbered discs. In order to assess the amount of brood, the combs with brood are counted, and additionally, the brood area of the central frames is measured. In this hive, the brood extends nearly into the corners of the frame, and the colony is awarded maximum points 4. For a fair evaluation, it is also necessary to look for brood gaps which may be due to inbreeding. This is made easier with a card with an opening which reveals precisely 100 cells of worker brood. The average of 3 to 5 counts made in early May represents the inbreeding factor. Another most important task is the regular evaluation of the colony's behavior. This requires extensive experience. This stock is very gentle and can be worked without smoke. The bees do not attack and do not sting. This is awarded top marks. After the inspection, all frames are returned in the original order and the hive is closed. All points awarded and other comments are entered on the record card. Some colonies can only be handled with full protection and with lots of smoke. Such defensive behavior is penalized in half-point steps, and this colony receives the lowest mark, 1. Another aspect of bee behavior is calmness on comb after its removal from the hive. When this character is pronounced, the bees form a dense covering on the comb. When the opposite character of running dominates, bees leave the exposed comb in a short time. Calm behavior is also evaluated with the 4-point scale. This patch of sealed brood shows many gaps. Some could have been caused when scattered pollen stores blocked egg-laying temporarily, but gaps to this extent are genetically linked and must be explained by the mechanism which determines sex in honeybees. About 11 different sex alleles are involved. Some of them are represented here as colored symbols. Each fertilized egg has 2 such alleles. When they are unequal, it develops into a female, a worker bee, or a queen. Eggs which normally produce drones are, as a rule, unfertilized. They have only 1 sex allele. When the 2 factors coincide, a diploid drone larva, a freak male, hatches from the egg. It is removed and a gap occurs in the patch of brood. Within a few generations, inbreeding can lead to a brood nest with many gaps. Normally, the spermatheca of a queen contains many different types of alleles. Fertilized eggs have sex factors in unmatched pairs. Female larvae will develop. Now a virgin queen mates with the drones of her mother's colony. 75% of all eggs have unequal alleles, while 25% have identical sex factors. So 25% brood gaps occur. When the granddaughter mates with drones from the grandmother's colony, half of all eggs laid possess alleles of unmatched types, while the other half has identical alleles. A brood loss of 50% results. During the swarming period, it is necessary to make weekly examinations of the colonies, apart from the regular visits for full evaluations. Frames are scrutinized for queen cells. When any are found, they are opened. In this case, they contain neither eggs nor larvae, and the colony is not in a swarming mood. If the first honey super is partially filled, the stock is given another one. This super contains frames with foundation and drawn comb. It is weighed and its empty weight is entered in the record book. This colony has swarm queen cells already containing larvae. A large number of swarm cells with well-provisioned older larvae are a sure sign that the colony is determined to swarm. All cells are destroyed. Whenever the swarming fever is that far advanced, it is not possible to suppress it by adding supers or by the destruction of queen cells. Swarming can only be controlled by making a temporary parking nucleus with the old queen. After lifting off the upper brood chamber, all frames are carefully examined and all queen cells are removed. The marginal areas of drone combs should not be neglected either. In preparation for the next step, one frame of open brood